Hello viewers, welcome to another video. In today's video, I will show you how to interface a stepper motor with Arduino Uno using a stepper motor driver L293D. In this video, I will first write Arduino code in Arduino IDE software, then I will build it up and generate hex file, and then at the end of the video, I will simulate the whole circuit in Proteus 8.12. So stay tuned till the end of this video so you will better understand how to interface a stepper motor with Arduino Uno. First of all, open Arduino IDE software. I've already written a C routine in Arduino IDE software. I will explain each line step by step in order you to understand the function of each line. So first of all, from the file, select open. I will select the .ini file where I saved my code, stepper motor, and this is .ini file. Double click it. So the first line is to include stepper.h. We include the stepper library which has pre-written functions to control stepper motor. Without this header file, we would have to write the sequence of coil energizing manually, which is complicated. The next line is const int steps per revolution equal to 100. So the steps per revolution depends on your stepper motor. This function tells the Arduino how many steps the motor takes to complete one full rotation. The stepper motor which I am going to simulate in the Proteus has a step size of 3.6 degree. So for full rotation of 360 degrees, it requires 100 steps to rotate in order to complete one revolution. So our step per revolution is equal to 100. The next line of code is stepper, my stepper, and within the arguments are steps per revolution 8, 9, 10, 11. So what we have done, we have created a stepper object in which there are 5 arguments. The first argument is again the step per revolution. The next 4 numbers are the Arduino pin numbers connected to L293 driver input. So this command setups Arduino to control the stepper motor correctly. So this function setup runs once when the Arduino start. MyStepper.setSpeed function sets the speed of the motor to 10 revolution per minute. You can also increase or decrease RPM to make the motor rotate faster or slower. Next, this is an infinite loop. Inside this loop, we have again have the for loop which runs for 50 instructions, and each time MyStepper.step1 moves the motor to one step clockwise. There is a delay, and after the delay it will increment again. The MyStepper.step moves the motor to one step until the 50 steps have completed. If you want the motor to rotate one complete revolution, the for loop will run for 100 increments. Similarly, the next instructions will be to rotate the motor in counterclockwise direction. For that, we have to write -1 in the argument of MyStepper.step. This is the delay between the counterclockwise and clockwise rotation of the motor. So this completes our routine. So once you have written the code in this window, what you have to do, go to the tools and you have to select the board. Click the board. From Arduino AVR board, select Arduino Uno since I'll be using Arduino Uno board in Proteus simulation. After selecting the board, the next step is go to Sketch and export compiled binary. If there is nothing wrong in the code, it will compile the code and generate hex file. Normally this software generates the hex file in the same folder in which the .ini file is located. Here in the build folder, you can see all the compiled files, which also include the steppermotor.ino.hex file. Now, the next step is we have to draw the circuit in the Proteus software. I have already placed all the required components of the schematic and also did the connection between all these components. The main components we required are Arduino Uno board, the L293D driver, and a stepper motor. I have connected pin 8 to 11 4 pins with this driver, which I have also initialized in the code, and the outputs of this driver are connected to the stepper motor. Once you have connected all the components, the next step is double click Arduino, go to the program file, select the folder, and select the hex file which you have just created. Now run the simulation and the motor starts to rotate in counterclockwise direction. As you have remembered that I have used 50 steps in for loop, therefore it will rotate to 180 degrees half rotation, and then it will change its rotation and start moving towards the clockwise direction. Now if you want the motor to rotate for one complete rotation, you have to change this number from 50 to 100. So it will rotate one complete rotation in one direction and half rotation in other direction. Again from the sketch, export compile binary, then again run the simulation, and now you will see it will complete one complete rotation of 360 degree, and then the motor will rotate in the other direction. After completing one complete rotation, the motor is now rotating in clockwise direction. So I have given the link in the description from where you can easily download a sample.ini or C code file and also the Proteus simulation file. From the C file, you can easily change the commands in order to control the stepper motor according to your requirement. So for more interesting videos, stay tuned and don't forget to subscribe our channel. Thank you for watching.